In my last video, we looked at the mass spectrometer and how it can be used to analyse samples in order to determine the relative atomic mass of an element. In today's video, we're going to be analysing some mass spectrums of two common elements. We're going to start by looking at chlorine. Now, chlorine exists as two stable isotopes, and those two stable isotopes are chlorine 35 and chlorine 37. And as a rough percentage, we're going to be looking at the mass spectrum in a second, but as a rough percentage, I already know that approximately 75% of chlorine atoms will have a mass of 35 and 25% will have a mass of 37. We're going to look at how the mass spectrum confirms that in a second. So looking at the mass spectrum, we can see then obviously on the x-axis we have percentage abundance, and percentage abundance basically means how much of that isotope is detected. And on the bottom we have m over z. Now what does that mean? That means mass over charge. So to get the x-axis, we take the mass of the atom or the isotope and we divide it by its charge. Now, remembering in the mass spectrometer, this sample has to be ionized. That's one of the first steps. And the sample is ionized to form positive ions, normally singly charged positive ions. So in most cases, the charge will be 1+. So if we have a look at the mass spectrum, we can see two peaks. We can see one peak at MZ35, and we can see a peak at roughly MZ37. And in order to determine which peak is responsible for which isotope, we can take the mass and divide it by the charge. So we've got chlorine 35. If we're assuming it is a singly positively charged isotope, we do 35 divided by 1, which gives us 35. So this peak here is caused by the chlorine 35 positive ion, meaning this peak here, the 37, is caused by chlorine 37. Obviously has to have a positive charge because they're ionized in the mass spectrometer. The percentage abundance then gives us the percentage of how many of those atoms have that mass. So we can see that 75% of the sample had a mass of 35, and that the 25% of the sample had a mass of 37. Now we can use these two numbers to calculate the relative atomic mass of chlorine. How do we do that? Well, to calculate the relative atomic mass, remembering that relative atomic mass has the notation AR. So to calculate the relative atomic mass, we take the mass of the isotope and you times it by its percentage abundance. So it's the sum of all the isotopes, taking their mass and timesing it by their percentage abundance and dividing by the total percentage abundance. So in this case, to work out the relative atomic mass of chlorine, we take the mass of the isotope. So one of the isotopes has a mass of 35, and we can see from the mass spectrum that it has a percentage abundance of 75. So it's going to be 35 times 75. And then we add to that the mass of the second isotope times by its percentage abundance. So that's 37 times by 25. We divide it all by the total percentage abundance, which in this case is 100. And you should get an answer of 35.5 to 3 significant figures. And if you look in the periodic table, you will see that chlorine's relative atomic mass is 35.5. So you can check your answer to the periodic table to make sure that you have got the correct answer. The second example we're going to look at is bromine, because bromine also exists as two stable isotopes. And those two isotopes are bromine 79 and bromine 81. And again, we're going to be using the mass spectrum to determine the relative atomic mass of bromine. So if we look at the mass spectrum, we can see there are two peaks, one at 79, one at 81. And obviously this is a rough sketch, but if this was a real spectrum, we would see that the 79 was roughly at 51%, and the 81 is just below at 49% in terms of their percentage abundance. So there are slightly more atoms with a mass of 79 compared to the isotopes that have a mass of 81. So now we can carry out the calculation to work out the relative atomic mass of bromine. We've got the percentage abundances and we've got the masses of the isotopes. So to work out the relative atomic mass of bromine, you take the mass of the isotope times by its percentage abundance, add to that the mass of the other isotope times by its percentage abundance, divide it all by the total abundance, which again is 100%, and you should get an answer of 79.9 to 3 significant figures. And if you look in the periodic table, you can see that bromine does have a relative atomic mass of 79.9. You could also be asked in a question to write the ions that are responsible for those two peaks. So how would you do that? Well, the one at 81, the ion that's responsible is obviously going to be Br81, but remember they are positively charged ions because they've been ionized in the mass spectrometer. So it's going to be Br81, 1 plus is responsible for that peak. And for the second peak here at 79, it's going to be Br79, 1 plus that's responsible for that peak. So when you're writing down the species that give rise to those peaks, don't forget to include the positive charge. To finish off the video, we're just going to go through a quick exam question. So here we have a question. A 20p coin contains copper and nickel. The copper used to make a batch of coins is analysed by mass spectrometry. The mass spectrum is shown below. So here we've got the mass spectrum. Calculate the relative atomic mass of the copper used to make the coins. Give your answer to 2 decimal places. So let's have a look at the spectrum. We can see that they have labelled each peak with the percentage abundance for us, which makes life much easier. So we've got 2 percentage abundances, one at 69.17 and one at 30.83. Now we just need to figure out the mass of the isotopes. So if we have a look at the MZ axes, we can see that the one with 69.17 percentage abundance has a mass of 63, and the one at 30% abundance has a mass of 65. So now we've identified those values, we can put them into the calculation to work out the relative atomic mass. So we take the mass of the isotope, first one is 63, times it by its percentage abundance, plus the mass of the second isotope, times it by its percentage abundance, divide that by the total abundance, which in this case again is 100, and that will give you an answer of 63.62 to 2 decimal places. Thanks for watching. For more chemistry tips and revision, hit subscribe, click on the like button and check out my Instagram page using the link below.